Hello, this is Marat Kurudinov. In this video I'm going to show how to create initial boundary datasets for regional run. In our case it's atmospheric river in California. This video is for NCAR users, those who have access to NCAR supercomputers, because NCAR has ERA5 datasets that we will use already available on the system. For those who don't have an NCAR account, please watch another video where actually I explain where to get data, how to download them, and how to build datasets. It's a separate video. So for NCAR users, here we continue. So by now you already should have created invariant datasets for this case. So let's see if we have them. So ls bnd, and we used some identifier CA, or CA California. So you see we have 6 files, invariant datasets: leaf area index, land mask, land type, lat long data, soil composition data, and terrain. So now we need to do other datasets. In this case, it's a particular case where we gonna simulate October, I believe 21st, or October 21st, 23, or some 23rd very strong atmospheric river event in California, 2021. For that we need particular date. We will start on particular date right before that event. So let's first build soil initial conditions. For that we edit file 2D init soil ERA5 NCAR. Okay, so here what we need to specify is just basically our grid, the ones that we used when identifiers that we used when we created invariant datasets, and date, this initial date of the run. So it's 2021 year, October 21st, and we start at 12 p.m. Okay, so everything else is just this one are just symbolic links for output data, and we're gonna save netcdf files if you want to look at the dataset. So this datasets that were generated, remember model only uses binary datasets, but netcdf files can be used to check the fidelity of data. This is just pass data to hourly ERA5 data at NCAR. Okay, so everything is in order. So let's just execute the script. So it will take some time, so we will pause the video. Okay, so we're done. You see, just check if temperatures look kind of in a reasonable range. It's various levels, and also the amount of moisture in soil. It's from 0 to 1 generally, so also looks fine. So let's see what was created. So now we have, in addition to our invariant datasets, we have soil init file. So this is just saying for which timestamp the data, the grid, that it's from ERA5. So this one is done. Okay, now let's create snow dataset for snow. You just can look at here, snow ERA5 NCAR. This is what we want. So it's already preset. So this is our grid and date. Also October 21st at 12 p.m. and usual settings here. Okay, so just execute. This is pretty fast, so I won't pause the video. Or maybe I will do. Okay, so it's done. So we have snow, interpolated snow to our grid in California, over California. So you see that maximum depth is about 28 centimeters of snow, and this is temperature of snow. Well, don't get alarmed with this. It's just fill-in data. Okay, so we're done with snow. Now we gonna create sea surface temperature, and well, sea ice is not needed here because there is no sea ice on this domain. So we have the following, yes, this file as SSTCI ERA5 NCAR. Okay, so what we have here? So for California, we don't, first of all, don't need this. Okay, so this is we need to specify a grid again. So this is our grid identifier. Now we need our dates. So it starts again at the same as our initial data sets were 2021, October 21st at 12 o'clock, and we will end the simulation on October 27th. And we will not use hourly data, we will skip some data, just we don't really need SST that often. We skip every 6 data set, like skip every 6 data sets, so it's like 6 hourly. Every 6 hours we will record a sea surface temperature that the model then will interpolate between those time stamps. And for sea ice, we don't even have it, but it will just fill the zeros. So usually, like I use like daily, so 24 hours skip. That's CDF out true. So that's basically all you have to specify. So now you need to execute it, and this will take some time because many timestamps. So I will pause the video. Okay, so it's done. It took several minutes. Alright, so we have some reasonable looking numbers here. Right, so now what is left to do, this is all we need to do for two-dimensional data sets, and now we need three-dimensional data sets such as initial conditions for wind, temperature and so on for atmosphere, and three-dimensional nudging data set for original runs. It's very important data set because that's how you specify your boundary conditions mostly got specified, and also interior of your domain nudge to that data, and also ozone, three-dimensional ozone data set. Okay, so for that we will use 3D init region. So we could have used a normal init NCAR because it doesn't really matter, it would prepare dataset for you too, but we will use with region because it will prepare it a little bit more accurate in terms of height levels, because instead of using like global height levels, it will use height levels over in relation to pressure levels for this particular place. So it's it's better to use this one. So this is what we're going to use, init region, 3D init region NCAR. So here we specify again date as usual. So our date October 21st, 12 o'clock. But here also we need to specify the longitude domain kind of boundaries. So boundaries in longitude, minimum, maximum, and latitude, and those you specify slightly wider than your actual domain. So you need to know your domain maximum and minimum latitude and longitude, and then just add some, like, I don't know, 5 degrees, so that the model could actually interpolate. You need to specify a little bit bigger data set so that model could interpolate to your grid. So those are right outside of the domain boundaries. So then you specify identifier so that your output data set would be identified. The thing is, these three-dimensional data sets are not interpolated to model grid. They will stay the same as ERA5 grid. That's the difference with these two-dimensional data sets. That needs to be precise because they basically, it's the difference between land and ocean and stuff like that. But for three-dimensional atmospheric data set, for atmosphere, model will interpolate when it starts. It will interpolate data to model grid itself, but in order to identify, we use this identifier that it's California limited domain case, original run. So that's basically that's the purpose of that. Again, three-dimensional data stored at binary data set for GSM run are stored on ERA5 grid, not. So and also it's much more economical than when we're talking about very high resolution runs, because ERA5 grid, even though ERA5 data is pretty high resolution, but it's still like close to 30-kilometer grid spacing. So data sets are much more economical in this regard, in terms of their size. Okay, so netcdf out. Okay, we will produce some data set to check our data, and that's basically all you need to specify. So we just now run, and it's relatively fast, so I will not pause the video even. So this is temperature, QCQI, yeah, done. Okay, so great. So now we prepare nudging data set, so it's 3D nudge, and again it's region, so it's more accurate, and it will create smaller actual data sets because it's only will create small regional data. Let's first look at it. Okay, so here we also because it's nudging, it's actually it's not initial data set, it's kind of evolving data set, so you need many time stamps. So you need to specify two dates, the start date, which is our October 21st 2021 at 12 p.m. and we end on October 27. And also here we specify all longitude and latitude limits and identifier California. Now output directory here I specified it as a full pass. This is where nudging data set, but it's best actually to create symbolic link, like I think I already created one. Yeah, for nudge symbolic link to that data set. So instead of specifying actual path, I will specify just symbolic link. Okay, and produce netcdf file, which is probably overkill but in this case data sets are not very large, so it's fine. Okay, so it's going to be hourly nudging data set, so every hour for this about 7 days. Okay, let's run it. Okay, it will take a while, so I will pause the video. Okay, so we're done. Let's see, ls nudge our California case. So see, we have lots of files every hour, not only binary but NetCDF files, and also we have this ASCII file that actually contains a list. So you see it contains some information that needed by the model to interpolate data. Okay, so it's done. Now we need to make, which is left is ozone dataset. So this one is NCAR and region. Yes. So you specify for ozone, is in this case I use monthly datasets. There is no need to use like hourly or anything like that. So for that you need to specify starting, first of all you specify year, of course, and then you specify starting month, which precedes the month that of your dataset when your run starts. Like in our case it's October 21st, so we specify September 9, and it ends also in October, so we specify November 11. And then you specify identifier and coordinates of your data, maximum, minimum, longitude and latitude, same as before. And so now we just execute it. So it's going very fast. I would pause the video. Okay, so done. Let's see what we get. BND, California. Okay, so this is all the dataset we basically require to run our regional run of atmospheric river over California. So we have all these datasets that require exact grid, and also we have this just three-dimensional dataset that on ERA5 grid. So we have all the whole set of data we would need. So watch another video where I edit the name list for this run, specify everything, and then just run it, and then we will look how to convert output to NetCDF, and then look at some results, that in another video. So thanks for watching, and happy computing.